So now that you know a little bit about what capacitors are, we're going to talk about actually using them in a circuit. And so we're going to talk about series and parallel capacitors. But first, here's just a couple pictures. The first one is just what capacitors look like. And they're really very small elements in a circuit. And of course, if you're talking about the computer circuits and things, they're actually built in to the microchips in layers of metal and the dielectric material. And then you'll see the little symbol for the capacitor in the circuit diagram. Looks a lot like a power supply or battery, but both of the little lines are exactly the same length with a space in between them. It's not a switch, it's a capacitor. So when you're working with capacitors in series, that means that they're all hooked up in the same loop. And it's going to be opposite the resistor patterns that you see if you're working with resistors. So the equation to find the total capacitance is going to be 1 over the total capacitance is equal to 1 over capacitor 1 plus 1 over capacitor 2 plus 1 over capacitor 3 plus 1 over capacitor 4 and so on until you find the total capacitance. And when they're in parallel, it's like the resistors in series. So you're just summing them right up. And I have an example for you for the series circuit because it's a little bit more complicated and there's a couple things to remember about the math. And then I talk you through how to solve a combination circuit that's going to have series and parallel capacitors. So I have an example problem with 3 capacitors connected in series, and they're just little values that I picked. We have a 5 farad, a 3 farad, and a 6 farad capacitor, which is pretty big capacitors. And we want to know what the capacitance of the total circuit is. So for capacitors, the math for the series capacitor is exactly like the math for parallel resistors in a circuit. So you have to be careful, find a good common denominator, and then remember to flip it at the end. So we have 1 over the total capacitance, in this case 1 over 5 farads, plus 1 over 3 farads, plus 1 over 6 farads, which is going to be 6 over 30, plus 10, plus 5, which is 21 over 30 farads. So the total capacitance is 30 over 21 farads, which is about 1.4 farads. So you can see also one way to tell that you've got the correct number for your answer is it's less than the smallest of the capacitors. All right, so when you have a combination circuit, which is a combination of series and parallel setups, you've got to work through it step by step. And so you've got to identify the different parts that you can simplify. So I would start with this setup. We have a couple in series that are in parallel with another one that's in series, and that whole setup is in series with a fourth one. So if you had something this complicated, you'd start off by simplifying this into a single capacitor value. And then you'd go ahead and take these two and combine them into a single, and then it's just simply a series calculation. So you would start off with, let's just solve the series for 1 and 2, and then you would do the parallel calculation for 1, 2, and 3. And now all you do is the series calculation to combine that 1, 2, 3 with capacitor 4.